Hello everyone, I hope you're all doing well. So in today's video, we are going to go through the 2019 Northern Hemisphere Specialist Exam 2, the extended response questions. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. I hope this video finds you well and helps you with your specialist studies. Good luck. Let's smash through this paper. So question 1. In the complex plane L is a line with this equation. Verify that this point 0, 0 lies on this line. A really easy question. To verify this, what we can say is let Z, a point Z, be, you know this thing? We can write it as 0 plus 0i. Remember, that's the same as the point 0, 0. And what we can do is we can sub it in here and see if this equation holds true. And if it does hold true, then we've actually verified that. So what we can say is this. We can say, putting this, in there, so like, it's going to be basically the absolute value of 2 is equal to basically -1 minus root 3i. So if you sub this into this equation. Now what we're going to do is we're going to look at the left-hand side and we're going to also look at the right-hand side. And hopefully they're equal. So we can say, we're going to say left-hand side is equal to, what's the absolute value of 2? It's just 2. What about the right-hand side? So what's the absolute value of this complex number? Really easy. You take the square root, of course. What's -1 squared, which is 1? And what's -3 squared, which is +3, which is also 2. Now, can you see how the left-hand and the right-hand side are equal? Then we have verified that. So we can say, hence, so left-hand side equals right-hand side. A really nice question. Next question. Show that the Cartesian form of this equation is y equals -root 3x. A really nice question here. There's two ways you can actually show this. You can show it the normal way. So let's write normal way. I'll show you both ways. Normal way. So normal way is, of course, you let z equal x plus yi and you sub it into the overall, this over here. So let's do that. So let me use purple here. So it'll be basically, so if I sub in it, it'll be x plus 2 plus yi, then if I sub it in here, it'll be x minus 1 plus y minus root 3i. Let me kind of move this on the side. There it is. I think there's going to be a lot of algebra here, so I'm going to move this a little bit on this side. So look, I'm going to sub in that x plus y. I'm going to try to, simplify this. So y minus root 3i. Beautiful. And close the absolute value. Of course, to find the absolute value, we're going to take the absolute value. So it'll be x plus 2 squared plus y squared is equal to the absolute value of this statement here, which is x minus 1 squared plus y minus root 3 squared. And so imagine squaring both sides to get rid of that square root. We're just going to be left out with x plus 2 squared plus y squared is equal to x minus 1 squared plus y minus root 3 squared. And then let's expand it. So this bracket's going to be x squared plus 4x plus 4 plus y squared. And this one over here is going to be x squared minus 2x plus 1 plus, what about this one? It'll be x squared. Let me move it on this side. There's actually, I'm just going to move this whole thing to a little bit on this side here. Minus 2 root 3y plus 3, if I'm not mistaken. Yep. So now let's simplify some stuff. Like we can see how both sides have x squared, so these can get rid of it. You can also see y squared on both sides. You can also get rid of that, and just a little bit we can simplify some stuff here. We can see that this over whole expression. Let's write it nicely like this. This one over here, put that there, and put this over here. So let's bring that back here. All right. So what's 3 plus 1? This becomes a 4 here. So it's a plus 4 here, by the way. So let me just move that there. All right. Now, I'm going to bring this, 2x on the other side. So it'll be 6x. And what I'm going to do is both sides have 4. So you can actually get rid of this 4 here. It's constant 4. So we can do that. It's equal to -2 root 3y. We can divide both sides by 2 to get, we can get rid, so divide both sides by 2, we get 3 here. And so, divide both sides by -root 3. So it'll be -3 x over root 3 is equal to your y. And of course, if you rationalize this, which it becomes this, x over 3y. These 3's cancel out, and you're basically left out with what we were supposed to get. Here is your final answer. So we have actually shown that this equation results in this, and this is a way we show it. This is the actual typical way that you would normally see, like normally you would do this way. Let's also show the other way too, because it's better to learn lots of ways, just so you can whenever you get hard questions, you can actually break those questions down. So the other way we can actually do this is called the perpendicular bisector method. It's actually really easy. So let's actually consider what's happening. When you're writing something like this, when it's like a line equation written in its in the complex notation, think of it like this. Normally it would be written as this, like z negative a minus bi equals z minus x minus y, something like this. And you can see it's actually in that form. You can see that. So what you would normally do is you actually, the inside here, solve it, let it equal to 0 and solve for z and find the coordinate. So let me explain. So if I solve the inside for this one, minus bi equals 0, and hence z is, of course, just a plus bi. This is my coordinate. So it's a, b. This is my coordinate. So for example, this one here, do the same here. You solve this, it's going to give you negative 2. So which is just basically your coordinate is just negative 2, 0. Remember, when it has an I, it's the y coordinate. So just think of it like that. Let me write the whole thing out here. Yep. So also, yep, that's one equation. What about this one over here? Same thing. So you solve it, it's just going to be 1 root 3. A really easy question. So these are going to be our two coordinates. Let's understand. Let's draw like a nice Cartesian equation, and we can represent these points really nicely to show visually what we mean by the perpendicular bisector. So, all right. So imagine this point here is negative 2. So imagine that's 1 and that's 2. That's negative 2 right over there. And then 1, root 3. Let's say root 3 looks over here. Split these points. So that's negative 2, 0, and the other one is, let's say, root 3 is here. And you line them up, and you can see how there is this this is the actual line for it. What is the perpendicular bisector? It's basically a line that passes through the midpoint of this line. Can you see how it is passing through the midpoint of it? Right over here. This is what a perpendicular bisector is. And guess what? This line here is actually the line what we want to show, which is negative root 3x. It's the line that, that passes, it's perpendicular bisector is basically what it is. So how can we show that? Like, how can we show this is the equation? Well, of course, the easiest way is let's get some basis of it. Well, I know the coordinates of these. So, I know that's negative 2, 0. And I also know this is 1 root 3. Why don't I, because I know they are, it's a perpendicular bisector, these are perpendicular, meaning that if I find the gradients of these two, which means I find the gradient of this red line and find the perpendicular gradient, which is just negative 1 over m, I will find the gradient of this yellow line. That's the goal. So let's do that. So to find the gradient, we know gradient is just m, which is y2 minus y1. So it's basically like root 3 minus 0, which is just root 3. 1 minus 2, which is positive 3. That's it. This is the gradient. So of course we want the perpendicular gradient. And remember, the perpendicular gradient is negative 1 over m. Isn't that right? So doing that, we get basically negative 3 root 3, which of course you you rationalize, you will get basically negative root 3. Negative root 3. Perfect. So we've got the gradient of the yellow line. Now we also need a value that's in there. And that's easy, because you remember what we said? If we have these two coordinates, and remember how we said it intersects the line in the middle where it's the midpoint. So let's find the midpoint of those two coordinates. So midpoint, of course, is, remember, you add these coordinates up. So what's 1 plus negative 2, which is 1 minus 2, which is negative 1 over. And then don't forget you divide it by 2. And you also do that with that root 3 plus 0, which is just root 3 divided by 2. That's it. So this is your midpoint. Midpoint. So of course, using find the equation of a tangent, like formula, so it's y minus root 3 on 2 is equal to the gradient, which is negative root 3, x minus basically negative half, which is basically positive half, you can say. Positive half here. And so of course, expanding this further on, negative root 3 on 2 is equal to negative root 3x minus root 3 on 2. So bringing that root 3 on 2 to the other side, so this one over here, basically leaves us with y equals negative root 3x. And here's also another way we could show it using the perpendicular bisector. any of these ways you want to show it, you'll get the mark. So I hope this helps you out. So using the perpendicular bisector, it's really useful sometimes for some hard questions. Let's have a look at the next question. The line L can also be expressed in this form, where Z1 is a complex number. Find Z1 in a Cartesian form. So, like what we just normally do. So, what is, I think this question is so much easier if you use the perpendicular bisector method. Let me explain. What I'm going to do is what I just did. So, like, for example, I'm going to find the coordinate of this, which is, of course, 1, 0. 1, 0. And let's let Z be, Z1 actually, be A plus BI. So, meaning that this here, when we solve it, it will just be AB. And let's come back to our, I'm going to copy this here. I'm going to use this to help me out. I'm going to actually just duplicate this and bring it down here. All right. So let's understand. Where is 1, 0? 1, 0. Let's find where 1, 0 is. So I'm going to use a green line. So 1, 0 is 1, 0, which is over here. And AB, well, AB is any value, but of course, you remember, AB has to be around somewhere around here. Why? Because remember, when we're going to put this, can you see how it's nearly passing through the midpoint? The y equals negative root 3x. The yellow line actually passes like through the midpoint. This is our goal. So basically, this here, this coordinate here is 1, 0. And this over here is AB. Can you see? And it has to pass like this. Because remember the midpoint here? Remember the perpendicular bisector has to pass through like that. So AB has to be some values that are here. Perfect. So beautiful. How do I find A and B? Well, the most easiest case is actually just let's use the perpendicular bisector method to find the equation of the yellow line, which we already know, but using like values of A and B. So what did we first do? We found the gradient. So let's find the gradient. So of course, to find the gradient, M, it's, basically, y2 minus y1, so 0 minus b, which is negative b, over 1 minus a. If I'm not mistaken, 0 minus b, yep, 1 minus a. Beautiful. So what I'm going to do is, of course, find the perpendicular gradient, which is just negative 1 over b, which is basically 1 minus a over b. The perpendicular gradient. So now it gives me, I know the gradient of the yellow line. This is the gradient of my yellow line. I also need to find the midpoint. Remember, midpoint is really easy. So midpoint, what we're going to do is we add the x values, a plus 1, always divided by 2, and also the y value, 0 plus b, which is just b, divided by 2. Done. So this is my midpoint. Now let's make the equation of find the equation of a line using these values here. So of course, remember y minus, basically b over 2, equals the gradient, which is 1 minus a over b, x minus a plus 1 over 2, done. So this is my thing. I'm going to actually use my calculator to basically simplify this and in a nice form. Let's do that. So come to our calculator. Let's write it. 1 minus b over 2 equals 1 minus a b times x minus a plus 1 over 2. I'm going to just say solve answer comma y. And this is what I actually get. So let's just write this down. So let's write that down. Y equals, I'm just going to expand it on my head. So it'll be negative 2 a minus 1 x plus a squared plus b squared minus 1 all over 2b. Done. So this is my equation. So I'm going to actually do this. So I'm going to rub this out. I don't want this. So delete that. I'm going to just need this. Okay. Now I know this equation is equal to the y equals, negative root 3x. Of course, plus 0, the y value is 0. What I can do is equate them. So equate the gradient and the y value. So, for example, I know for a fact that the gradient for this one over here is negative 2a minus 1 over 2b. And that's equal, of course, this gradient here, is equal to negative root 3. What I can do. And also make another equation, which is the y coordinate. So which is basically a squared plus b squared minus 1, all being divided by 2b. And that's, of course, equal to 0 because the y value is 0 there. And there it is. We've got actually two equations which we can solve simultaneously using our CAS, and we can find a and b, basically. Let's do that. So we can just go menu, algebra, solve some equations, and go to so A and B we're trying to solve for, which is negative 2a minus 1 over 2b is equal to negative root 3, and basically a squared plus b squared minus 1 divided by 2b equals 0. Enter, and these are our values of a and b. Beautiful. Let's write those down. So your values are, so your z1 basically, our a value is negative 1 over 2, and our b value is negative root 3 on 2i. Beautiful. This is our answer. Not a bad question. Really easy. Perfect. I hope that makes sense. So let's go to the next question. Finding in Cartesian form the point of intersection between L and the graph of this. So we already know this here is, if you don't know straight away, this over here is a equation of a circle. Remember, an equation of a circle looks like this normally in the forms. You'll get something like z minus a minus bi equals some value of r, which is your radius. This is your radius, and this here, of course, you solve it, which is basically a, b. This is your center of that circle. So basically, imagine in this case, this over here, this here has a center of 0, 0. So the center of 0, 0. And the radius is 4. So, of course, we already know how to find it. We already know what the equation is. If it's at the center, it's going to be x squared plus y squared equals 16 in the normal Cartesian equation like form. So, which, represents this equation here. And, of course, we know the equation of the line L, which is, of course, y equals negative root 3x. And we're just trying to find the point of intersection between these two. So what I'm going to do is I'm going to sub this y into this x, of course. So it'll be x squared plus, so y is basically negative root 3x, all squared equals 16. So x squared plus 3x squared equals 16, which is 4x squared equals 16, x squared equals 4, hence x is equal to plus or negative 2. So we got the x values, and of course, so the coordinates are, so let's look at negative 2 first. So subbing negative 2 into any of these equations, but I'm going to sub it to the easier one. So if I sub in negative 2, it'll be positive 2 root 3. And subbing the positive one, so 2, will give me negative 2 root 3. These are your 2 points of intersection. Really easy. So yep, finding the point of intersection. Done. Next question. Sketch L and the graph of the circle on the Argand diagram. Really, really easy. So let's sketch the circle. Remember, it has a radius of 4 and starts at the center. Oops, not that. So like this. Ooh, why is that actually not right? Come on. Draw some smoother. Alright, so here is a nice circle. Beautiful. And so this here will represent it as the absolute value of z equals 4. And of course, we're going to draw the line y equals negative, root 3x, which is what? So let's understand how it really looks. Okay. So we're going to look at the gradient. Like, of course, it passes through the center. We know it passes through the center, but how? So if I find the, the gradient's negative root 3. So if I sub that into this, I get a negative pi on 3. Basically, what it does, negative pi on 3 is basically negative 60 degrees. So basically, it passes through, like, the gradient here, this is negative 60 degrees. So the line's going to actually pass like this. This is the the equation. This is what it will look like, which is now L, of course. That's how you do it. I just found the angle. So remember, this angle here is negative pi on 3. So I just found it out, and yeah, I drew it like that. Perfect. And you can actually just draw it using your, just draw it like, sub in points, blah, blah, but that really it's really easy to draw this one. That's it. Have I messed up anything? Done. Next question. Find the area of a sector defined by the parts of L where real of z is x is greater, real of is greater or equal to 0. So the real of z is the basically, think of it like it's this one. It's the, your x, axis. So it's like we're saying, hey, find the area of a sector defined by the part of L. So the L is the equation, the yellow one, where x is greater or equal to 0. So basically like this. So you're only saying take this part over here, from here to here. Oops, let me make it smaller. Actually, let me use a red line. No, it's actually not very visible, but let's say yellow, this orange. Can you see? This is where it's greater, x is greater or equal to 0 for that line. And the graph of, the circle where, again, x is greater or equal to 0, where the real is greater or equal to 0. So basically from here all the way to here, where it's only from there. And the imaginary axis, where the imaginary, so from y is greater than 0. So remember, this is your imaginary axis. So coming here, this is your imaginary axis. And we're saying from y is greater than 0. So basically all the way here. And so, yeah, where this actually is the sector. You can see that the sector is this part over here. This is the sector. So what I'm going to do, now I know where the sector is, what I'm going to do is I'm going to just highlight it nicely. Actually, let me highlight it with this color here nicely so we can know where it is. So it's this one over here. Just draw this nicely. Okay. So perfect. So this is our sector that we want to find the area for. So shade that region in. Perfect. So this is the sector. Now, yeah, we want to find it. So there, what's the area of a sector? Remember, have these all in your bound reference. So the area of a sector, we know. So the area of a sector is half r squared theta. So this is the area of a sector. So where, of course, r is this over here. The is this theta here, which is the like the angle, and r is the radius of this sector, which is this over here. The radius. So in this case, our radius is of course 4. So let's write at the start. So area is half squared 4 squared. And what's our theta? Of course, in radians. Well, it's actually quite easy because we know every little part of this gap is 30 degrees, which is pi on 6. So imagine there's like 1, 2, 3, 4, 5. There's 5. So think of it like there's 5 of them. So 5 times 30 degrees, which is pi on 6. It's 5 pi on 6. So that's my also angle. Done. That'll give me area is equal to, so 4 squared is 16. So 16 times a half is 8. So it'll be 8 times 5 pi on 6. Of course, these can be simplified. That becomes a 3, that becomes a 4, which actually becomes 20 pi over 3 units squared. So this is your area. Beautiful. Done. Not too bad of a question. All right, so there it is. Next question. Question 2. Consider the function f with the rule of this, so f of x. State the equation of the asymptotes of this graph of f. Easy. So we can actually see that this actually can divide to this. So there's going to be a remainder. So what I'm going to do is I'm going to go to my cast. I'm going to define this. Let's control N this whole thing here. I'm going to say f of x. I'm going to define this function. F of x is x squared plus x plus 1. X squared minus 1. And I want to find the equation of the asymptote. So easy. We just write expand f of x. And here it is. So I'm going to write this equation right in my my iPad. So let's write that down. So it's f of x. I can rewrite f of x like this in its proper fraction form. So negative 1 over 2 x plus 1 plus 3 2 x minus 1 and plus 1. Done. So of course the asymptotes are what? Well, there's a y equals 1. So y equals 1 asymptote. Y equals 1. And we also have these ones here, which is x equals negative 1 and x equals positive 1. X equals negative 1 and x equals positive 1. These are your asymptotes. Really nice question. State the coordinates of the stationary points and the point of inflection. Give your answers correct to these decimal places. Really easy. So we already know how to find those. So we know to find stationary points, it's when you let f dash of x equal 0. And that results, of course, in stationary points. And we know to find the point of inflection, it's when you let the double derivative equal so inflection. So you let the double derivative equal 0. Let's do this in our cast and get the answer. So what I'm going to do is I'm going to derive first f of x, find the stationary points equals 0, and I'm going to solve answer comma x. So these are my x values. These are my x values, and I want to find the y values too for them. So I'm going to sub this first one in there, and f of let's leave this over here, and let's write those down first. So let's write those down. So the first one is negative 3.73. The y coordinate was 0.87. The other coordinate was, negative 0.27. The y coordinate was negative 0.87. So these are my coordinates. Done. If I haven't made any mistakes on rounding up. So also I'm going to find the point of inflection. Let's go back. So the final point of inflection is when we let the double derivative equal to 0. So that's my x coordinate, and to find, of course, the y coordinate, I'll sub it back into the original function. So let's write that also down. All right, so this one here is, negative 5.52. And the other one's 0.88. Done. Really nice, easy. Let's look at the next question. Sketch the graph of f from x equals negative 6 to x equals 6. Endpoints coordinates are not required on the set of axes below. Label the turning points and a point of inflection with the coordinates correct to, 2 decimal places. Label the asymptotes with the equation. Really easy question here. So we know the asymptotes where y equals 1. So let's draw those. Oopsie. Let's use this color. So, yep. So, y equals 1. Can you see actually? I don't think so. Let me use a red then. Y equals 1. So, y equals 1. X equals 1. Which is over here. And x equals negative 1, which is over here. Done. So we've labeled our asymptotes, and now what we can actually do is put these points here, label them here, and then we can just use our CAS to know what the graph of the shape looks like. So the first point is negative 3, which is here, 7, 3, so somewhere around here. And then the y value is 0.87, so 0.8, so 2, 4, 6, 8, so around here. So around right over there. So if I can, right over there. That's the first one. What about this one over here? It's negative 0.27, so that's negative 1, that's negative 0, so it's around here. And 0. So 2, 4, 6, 8, somewhere around here. Done. So that's the other one. And then, of course, we have this one here, the point of inflection, which is negative 5. So that's negative 4, negative 5, negative 5, negative 5.5, which is around here, and 0.8, which is close to this one over here. Yep, so negative 5. Yep, around there. Done. So we've kind of got the coordinates of how they are located. So let's actually use our CAS and to look at the shape of what it's supposed to look like. So going back to our CAS, let's go to our CAS, f of x. And what I'm going to do is I'm going to make sure it looks the same as what's on my paper. So go on menu, graph, window zoom. So my x minimum in my, is negative 6, 6. So, and every scaling goes by 0.5. The y minimum is from negative 2 to 2. And the y scale, every scale goes by 0.2. Enter that. And it looks like that. Go menu, view. And I'm also going to make the grid look like that. This is how my actual graph looks like. Perfect. And don't forget, there's a y equals 1, 1, like the asymptote, and of course the other asymptotes, which are x equals 1, x equals negative 1. These are also asymptotes. So it actually looks like this, basically. You want to just copy and paste this, basically, in your table. So let's do that. So I'm going to use the color this. So I know that it's going to look like this. It's going to pass like that. So that's the first one. I'm also going to have something like that. Oops. That. And I'm also going to have something that looks like that. Perfect. And don't forget, there are endpoints, actually. They're endpoints. I'm always kind of forgetting, but they're endpoints. We don't even have to label them, but they're kind of endpoints. So just like that. From that, and these, it's an endpoint here. Try that nicely. And this here, take that out. So from there to there, it looks like that. Perfect. And let's label those points here. So this point was here, was our what was it? That -5 one. So it's that -5.52, 5.52, 0.88. And this one over here was that -3.73, 0.87. And this one over here was my stationary point, which was, you know, negative 0.27, negative 0.87. Done. So that's all you need to label, I think. Yeah. So we've labeled the asymptotes, we've labeled the stationary point and the inflection, and that's basically it. Beautiful. Next question. Consider the function f of k where the rule of f of k is this, where k is an element of all reals. For what values of k will f of k have no stationary points? All right. So let's do this with our CAS, actually. Let's go to our CAS and define this function. So f of k, let's define it. So f of k is x squared plus x plus k, x squared minus k, minus 1. There it is. So what I'm going to do is, to find stationary points, we know we need to derive f of k and let it equal to 0. That's how we find stationary points. Jackpot! If you don't see this, this is actually a quadratic on top. What we want to do is we want to make sure this doesn't exist. This quadratic here. Let's actually write this whole part here at the, let's write this down in our paper and I'll explain what I mean. So let's write this down. So f dash of k of x is equal to negative x squared plus 2k plus 1 x plus 1 all being divided by x squared minus 1 squared equals 0. That's what we want to do, yeah? We solve it to equal 0. Now, of course, you know, the bottom part, you know, equals 0, you know, it cancels out, disappears. Now, we want it to not exist. We want to find, so, like, how do we make this not exist? Especially it's actually a quadratic. If you actually look at this, this is a quadratic. Let me write it. Let me expand it and make sure it looks, actually, like, you know, take the negative out. This is a perfect quadratic. You can see because you divide both sides by, you know, like a -1, you know, it cancels out. So this is what you get. Look, it's a quadratic. So we got the x squared, like, you know, we got the here x squared and we have the x here and we have the 1 here. So to make this not exist, if we don't want no stationary point, we want to make sure that the discriminant is less than 0, so we don't even have any solutions. Let's do that. So we want the discriminant to be less than 0. So we know that the discriminant is what? B squared minus 4ac. So let's do that. So what's my b squared? Well, it's actually my 2k plus 1 squared minus 4, a is 1, c is 1. So basically that is to be less than 0. You know, squaring everything, so 4k plus 1 squared. Bring that 4 to the other side. Divide both sides by 4. We get, you know, 1. And I'm going to solve this in my CAS. I'm not even going to think of doing this. Just let me do it by CAS. It's so much easier. So basically, I'm going to solve where, you know, k plus 1 squared is less than 1, comma k. Which is k is between -2 to 0. So let's write that down. So k is between -2 to 0. Now what I'm going to do is I'm going to actually check this with my CAS. Always check these with your CAS. I think one of the most biggest flaws about specialists is always when you get a k value, check it. Does it actually have no stationary points? Let's do that. So from k has to be -2 to 0. So what we can do is straight away go on our CAS. So I'm just going to make a new problem so I don't mess around with my values. I'm going to define this. Put it right over here, and I'm going to actually graph it. Fk of x. There it is. I'm going to graph it. And here it is, yeah. And remember we said from the values are from -2 to 0. And we can, let's see. And as you can see, yes, you can see that there are no stationary points over here. Of course, like if we did, like let's say 1, which is above that value, you have some stationary points here. But yeah, values here. Wait, so we're not including 0 and -2, but look, if we plus 0, there's no stationary points. And what about -2? There's also no stationary point, but if we go above those, like -2.1, then we hit stationary points. So actually, -2 and 0 are also included. That's so yeah. Like if I put 0 here, so those values are actually included. Like so it says the value we didn't include it, but it's actually included. So 0, look, it has no stationary points and every value between them. But when it hits also -2, there's also no stationary points here. So yeah, we're supposed to actually include those k-values. This is the part with I'm telling you, specialist is really tricky because the best thing that I always tell students is to, yes, you get the values, but check them out using your CAS. Use a slider to check those out. So it does, just be careful. We need to actually include those values. So put a less or equal there. So that's your k-values. Next question. For what value, so there's only one value of k will the graph of f of k have a point of inflection located at y of the y, axis? So really kind of easy. So we want a point of inflection on the y-axis. So we know how to find a point of inflection, yeah? It's when you sub in, when when the double derivative is equal to 0. Now, if it occurs at the, what do we call it? If it occurs at the y-axis, isn't it, in the y-axis, isn't the x coordinate always 0? So can we just sub in here 0 and solve for this for k? That's what we can do. So let's go to our CAS and let's write down. So what we can say is, where's the, so go to, double derivative here. Fk of x equals 0, which is this. I want this when x is equal to 0 because that's where my coordinate is. My y coordinate always occurs at x equals 0. And I can solve this answer, comma k. So k is equal to -1. I'm just going to check it using my slider here. So if I sub -1 here, yes, look, you can actually see it, that this the point of inflection is on the y-axis. So k equals -1. Let's write that down. K equals -1. Done. Next question. Question 3. All right, so a vertical cross-section of a barrel is shown above. The radius of a circular base along the x-axis is 30 centimeters. So basically, let me use a different color. So this part from here to here is 30 centimeters. And the radius of the circular top is 70 centimeters, which is this part from here to here. Is that 70? Yeah. So let me, wait. So 70 centimeters. 1, 2, 3, 4, 5, 6, 7. Yes, it is 70. Yep, 70 centimeters. Makes sense. The curved sides of the cross section shown are parts of the parabola with this equation. So yes, so this part here, these two here are from these parabola. The height of the barrel is 50 centimeters. Yes, you can see that right over there. It's 50. Show that the volume of the barrel is given by this. A really nice question. So the volume, we know always volume is pi. Now let's think about this. To get the volume of this barrel, the whole barrel, what we can do is we can look at this part over here of this parabola, this part over here. Let me highlight that part. Let me use a little thinner one color. We can highlight this part over here. And if we rotate this around the y-axis, we will get this nice actual ball. And that's what the volume is. So what we want to do is we want to get this part of this parabola, which is from and rotate it around the y-axis. So dy means I'm going to rotate it around the y-axis. It means these values here have to be in terms of y, which is the height. So remember, what's the height of this part here? It's 0 to 50. So 0 to 50. And remember, inside you have to put x squared. So this is your x squared there. Done. Let's put that there. Now, all right. What's my x squared? Well, I've got my equation, so I'm just going to solve for it when it's x squared. So bring that 45 over 4 on the other side and multiply both sides by 80 to actually get rid of that. So it becomes x squared. So expand that out. So 80y plus, so 20 times 40, 50, which is 900 equals x squared. So we can actually sub that in there, and so we should get the same equation. A really, really nice question to start the paper. So it's 900 plus 80y dy. There it is. A really nice, perfect question. Find the volume of the barrel in cubic centimeters. So just put this in your CAS and you should get the answer. Let's do that. So I'm going to get control in this whole thing here. I'm going to write that down. So pi times the integral from 0 to 50. Sorry, what the hell is that? From 900 plus 80y dy. Enter, and we get this here. Perfect. So that's your volume. So our volume is 145, 3 zeros, pi units cubed. So it's a volume. Done. Oopsie. Let me just make it. There it is. Perfect. That's not nice. Let me just make it nice. Okay. Yeah. Let's move on to the next question. So it says the barrel is initially full of water. Water begins to leak from the bottom of the barrel such that this is that. So dV dt is that. Okay, cubic centimeters per second, where T is the seconds, the depth of the water is H height meters. Makes sense. The volume of the water remaining in the barrel is V cubic centimeters, and the uppermost surface area of the water is A square units. So A represents the uppermost surface area, meaning that this, the water here. So imagine right now the water height's here. So imagine right now the water's here. Yep. This is this surface area over here of the water is called A. It's the area of A. And makes sense. All right. And so show that dV dt is that. So we know dV dt is there, but we just need to find A basically and sub in A, which is the surface area. Quite easy. Let's do that. So what is the surface area? Okay, now the surface area of the water could be anywhere. Remember, it could be right over here. Remember, it's decreasing at a rate, at some rate. So let's consider right now, if it was at this position here, let's consider it, what would happen. So if it was this over here, what do we know? Well, I'm trying to find the area of this surface area, which is what? How do you find the area of a circle? We know that, area of a circle is pi r squared. And so we need the radius, this radius. Now, remember, this radius changes. This radius changes. From here, it was this. Well, what is it? Isn't just the radius the x value of our values? You know how it's going to change? Like, if it was here, if the water was here, this was the radius. Look, can you see the x value changes? Yeah, the x value changes. So imagine this is. Imagine this here. This here is also known as x. It's the radius is also known as x in this case. So radius, it's also x. And so, perfect. So the radius is x. So we can say pi x squared, because the radius is squared. Okay. Now, the question doesn't want it in terms of x. It wants it in terms of h. So, now what do we, well, h is just the height of the barrel. When, in terms of when, yeah. So for example, can you see how, if the water is at at this, if it's filled up to this, of course, this is the, and this is the height, of course, this is your h. So basically, the y value is your height. The y value is your height. So for example, this here, the y value is the height, so I can put h, and the x value, which is this over here, the x value is, of course, your radius. So if I actually write it as x squared over 80 minus 45 over 4, what I can actually, which is just this part here, so let me rub that out, which is just this part here, actually, considering it's just this here. I'm going to duplicate this part. It's actually just this part. Duplicate. I'll put it up here. So come back here. All right. So we know the y is the height. The y is the height, and the x squared, which is basically the same as radius squared. So can we just sub this? You know how this is a radius squared, yeah? Just put pi in front of it. Multiply pi in front of it, and we should get pi r squared. So this here is actually your a value. Damn. So this is actually your a value. So let's write that down into our equation. So we know that dv dt is negative 8,000 pi root h, and a, where a, I'm just going to copy this part here, bring this down here, which is there. Let's write that nicely down, which is pi 80h plus 900. Done. I'm gonna rub this out. I don't want that there. Okay, and we're just gonna cancel some stuff out, like pi. They both have pi, so these pi's can cancel out. Also, you can see how you can also see like how you can cancel. Both have like zeros on top, so I can cancel this 1 0 here, 1 0 here, and 1 0 here. Just a little bit simplifying that much further, which looks like this. They have a common factor of also 2, so we can divide both sides by like the top and bottom by 2. So this will be 400. This one. This one here will be 4, and this will be 45. And there it is. We actually have shown that it's equal to that. Now, I haven't actually really shown nothing because I didn't write nothing here, but I hope that makes sense, like all the working out. So you would like show, of course, the area formula that we got, how we got it, like this here, this part, of course, showing that pi squared equals this. You want to show all this working out that I've done here, and you should get the mark. So like this part here. So So the area is also given by this. So you can put that down here. Oops, come on. So you can put this area formula here. How we got the area, and yeah, sub those in there. Done. Makes sense. And of course, you would show like you were simplifying. I just kind of rubbed everything out, but I hope that makes sense. Next question. Find DHDT in terms of H. Express your answer in this form where A and B and C are positive integers. All right, so DHDT is going to be equal to, isn't it just DH dot dv, so dt. Because these dv will cancel out. And we already know what dv dt is, which is over here. How do we find dhdv? So the volume in terms of height, which is actually not hard, because coming back to this question, it's basically we're saying this. How can we get the volume at any point? So like here. So imagine like, you know how this is your height? This is your height. Imagine this is the barrel and this is your height, of course. And how can we relate the volume and the height? Well, it's easy. It's just, how do we find the volume? How did we even find the volume? Didn't we use this? So volume is just pi integral from, let's say, 0. So, we started from 0. The barrel starts from 0. And the height was the max. But here, imagine that height is the water height, where we're going to consider it as just h. 0h. And the volume was using, of course, so dh, and it was x squared inside, which was that formula over here, the one that we used over here, which was this over here. Okay, duplicate that, put that there. And put that, basically, it's 80. Y is h, of course, plus 900. Leave that there. Now, look, the big difference between this is that y was our value, but here in our writing is h, because h, of course, varies. Height, it's the water height, basically. So this is basically it. This is what you want to kind of show you right here. And let's bring that down. And we can actually use our calculator and let's just simplify this. Let's write that down. So how we're getting our value here. All right. And this gives us a volume of what? Let's use our calculator quickly. So basically, I'm just going to copy this actually and just change some stuff up. So that's height. This is h. This is h, basically. Enter, and this is my value. Of course, this is actually like v equals, like it's a volume equals in terms of height. But I want to derive it because I want to get dv dh right now. So in terms of height, I derive this. I get this. Yep, that's my dv dh. But I want dh dv, which is the reciprocal of it. So 1 over this, sorry, no, what the hell happened? So 1 over that is this. So that is my, basically my dh dv. So let's write everything that we wrote down in my thing. So when we, when we did this, we got 20h, 2h plus 45 pi. And we then derived it, which gave us dv dh, which gave me, which was 20, 4h plus 45 pi. And then I reciprocated, which gave me dh dv, which gave me 1 over this value here, which is 20, basically the same thing. So 20, 4h plus 45 pi. Done. So now I got my dh dv, and I also have my dv dt. I just have to multiply them. So let's multiply these values. So this and that here. So it's basically my overall dh dt is 1 over 24h plus 45 pi times negative 400 root h all over 4h plus 45. So, which is basically like, these are gonna, so these, you can take these out. Just putting everything together, this part goes here. These actually have the same thing, so we can rub that out and put a squared here. Okay, so let's see some stuff that we can kind of cancel out here. So we can see that we can, cancel these zeros here, these zeros here. We can cancel this. This becomes negative 20. Bring the pi here. Yep, so I'm trying to make it the same thing. So it's actually 45, because it's supposed to be b plus ch. So it's actually be 45 plus 4h. So 45 plus 4h. Which, yeah, this looks like the answer. Done. So it's in that form. Not a bad question. Really nice. There it is. All right, so that's perfect. Next question. Using a definite integral in terms of h, find the time in hours. Be careful, in hours. So I think the other one was in seconds. Did we talk about seconds? Yeah, it was in second. So, okay, be careful with that. Correct is 1 decimal place taken for the barrel to empty. Easy. So we got this dh dt. So let's write that down. So actually reciprocate it first. So dt dh, because we got it in terms of h. Because we're going to write a definite integral, which is basically the reciprocal of this here. 4h squared equals negative 20 root h. So if I integrate this, I'll get the time. So if I integrate this expression over here, I'll get the time. So if I just kind of duplicate this and put this right over here, in terms of dh, in terms of height, yeah. So, but where am I going? Well, we're saying use a definite integral in terms of time. Correct. To 1 decimal taken for the barrel to empty. So we started, didn't we start the barrel? Yep, the barrel was initially full. So if it was initially full, what was the height? Well, it would have been, 50. So we're going from 50 to the height of 0. So because it's going to be empty, and so we can put this in our cast. Let's do that and let's evaluate this. 50 to 0, which is pi times 45 plus 4h squared negative 20 root h dh, and so equals control enter this value over here. Now be careful, remember this was in second, we want it in hours. So what we want to do is first take the first figure here divided by 60. This will give me in minutes now, and take this again divided by another 60, and we should get in hours, which is this value over here. So how much do we want it? To 1 decimal place, but that's basically 9.9. So this value here is 9.9 hours. Not too bad. There it is. Question 4. Let's do this question here. All right. So it says a snowboarder at the Winter Olympics leaves a ski jump at an angle of theta degrees to the horizontal, rises up in the air, performs various tricks, and then lands at a distance down a straight slope that makes an angle of 45 to the horizontal as shown. Let the origin O of the Cartesian coordinate system be a point where the snowboarder leaves the jump, with the unit vector in the positive x direction being represented by I and unit vector in the positive y direction represented by j. Distance are measured in meters and times measured in seconds. The position vector of the snowboarder t seconds after leaving the jump is given by this. Beautiful. Find the angle theta. Yeah, so basically this RFT function gives you, like, if you sub in any value of t, like, at 0 seconds, he should be around here. So sorry, at 0 seconds, he should be starting at here, where he was initially start. If I sub in, like, in 1 second, he should be here. 2 seconds here. 3 seconds. So you just, basically this here gives him the position. Basically gives you the position and, yeah, of his thing. So we want to find the angle theta. So that's actually not hard, because if you think about it, so what we can do is, okay, if I find the gradient of this position, basically think of this as displacement. If I find the gradient, it will give me the velocity. So for example, if I found out that, if I draw a tangent at here, remember a tangent in this case is velocity, because if this here represents position, and when you derive it, isn't it tangent, like gradient? So and if I sub in 0 especially, it will actually give me this gradient, this tangent. And remember these here, the I and j components tell you the x and the y coordinates. So for example, if I sub in t equals 0 for r dot t, the r dot means the gradient when I derive this, which is velocity. This represents velocity, of course. And if I sub in 0, it actually gives me this over here. It will give me the ij component of this, which is basically, remember, I'll explain that. So this is your I and this is your j component. So it'll give me these two components, which I can actually just use Pythagoras, like not even Pythagoras theorem, to find theta, this theta angle here. So that's how you would do this question. Really nice question, a really typical question that comes up in papers most of the time. So what I want to do is to find angle. First, I'm going to find the grade, the velocity when it's equal to 0. So let's actually define this function in our cast. Control N in this, and let's define first the position one, so which is just r of t, is defined as, so what's the I component? So it's 60 minus 0.01 t to the power 3, comma, then the other component 6 root 3 times t minus 4.9 t squared plus 0.01 t to the power 3. I hope that I haven't made any mistake here, actually. Just double checking. All right, looks actually good. So enter. So I'm gonna derive it so I can get r. In terms of x, in terms of t, of course. This is my velocity basically. And remember we said we want to let this equal, when t equals 0. And here is my x component and here's my y component. Let's write those down. So basically this here would mean that this part over here, the x component is 6 units. And the j component here would be 6 root 3. Yep. So you know how this is of course the opposite and this is of course the adjacent. I can use tangent to find that theta. So first let's write this down. So this here is just, it would give me 6i plus 6 root 3j. So my, to find the angle, it's just the tangent of the opposite, because you remember towa, so opposite over adjacent, which is 6, which is basically tan. So these 6's will cancel. It's just tan, root 3, which is pi on 3, which is 60 degrees, because we want in degrees, by the way, which let me write it nicely. So let me write it actually all nicely. Pi. So it'll be root 3, which is pi on 3, which is actually equal to 60 degrees. Done. Really nice question there. Next question. Find the speed in meters per second of the snowboarder when she leaves the jump at 0. Easy. So we're basically trying to find this here. So we're trying to find this velocity over here, this part over here. It's basically what we've done here. When we subbed in 0, this iron component, it's just, finding the magnitude of this, because remember, speed is the magnitude of this velocity. So we're basically just trying to find this. The magnitude of this over here, because you remember this is the velocity at 0, which is when she jumps. And what's the speed? Speed is just the magnitude of the velocity. So let's use our CAS here. And so we've got the, that, we just need to find the norm. Norm means magnitude of this over here, and it's 12. Let's write that down. 12 meters per second. Done. There it is. Next question. Next question says, find the maximum height above O reached by the snowboarder. Give your answer in meters correct to one decimal place. Really nice question. So let's rub these parts off here. All right. So of course the maximum height occurs over here. Right over here. The cool thing about the maximum height, what really defines the maximum height is that the actual vertical velocity at the maximum height is actually 0. Because think of it, when it's here, the maximum the velocity component is up. But when it's here, it's actually 0. But when it reaches here, then it goes down. So basically over here, the velocity component is actually 0 at the maximum height. So we can actually use that to our advantage, because if we know, so let's write this down here. If I know that the j component, j means the height component, the j component of r of dash, or r of t, which is the velocity component, is what? Let's write that down. So of course we know what it is. Going back to our CAS, it's this part over here. Let's write that down. So it's 3t squared over 100 minus 49t over 5 plus 6 root 3. And remember, it equals 0, because we know that the vertical component at that position, at that height, we know that the at that maximum height always equals 0. So using this, let's go to our CAS to take this pi here equals 0. I'm going to solve, answer, comma t. And basically control enter, and we get 2 t values. Now I don't know which one it is. These are basically both possible because t is greater or equal to 0. What I'm going to do is, remember, we want the maximum height. So you know how height, so the position, so which is r of, I'm going to sub in the first one. And remember, control enter. So remember, this is the x component, which is the horizontal distance, and this is the height component. Look, it's 5.5. Looks great. What about if I sub in r of the other one? Absolute rubbish. Look at it. It's negative. It's below. So this is our actual maximum height. So we got the time and the maximum height. So let's write those down. So the time it occurs, time is like 1.063 basically. And the height is to how many decimal places? To 1 decimal places is 5.5. 5.5 meters. Really nice. There it is. Next question. Show that the time spent in the air by a snowboarder is this. I swear I've seen this question before, like in one of those old VCAR papers. I don't remember, but I've seen this question. Yeah, it's really easy. So yeah, show that the time spent in the air by the snowboarder is this, seconds. All right, so let's come up here. Okay, so we know that whoever lands here. No, it's over here. And it lands, can you see how we can easily find the equation of this because we know the angle is 45, which is pi on 4, yeah? And so think about it. Using a tan pi on 4, we can find the gradient of this line, which is, by the way, it's negative pi on 4 because it's below, so it's actually negative, which is negative 1. So we know the gradient's negative 1, so, and it passes through 0. Isn't it just y equals negative x equation? Can you see the gradient's negative, which fits this, and it's also passes through the y value is 0. So there it is. This is the actual equation. And can you see how it's just a point of intersection? It's that point here, the time and we want to find that time it takes. Isn't it just a point of intersection between this over here and this equation, this straight line here? And that's actually easy because if you think about it, don't we know these components here? You remember this I component is the x component? And this component over here is the y component. So what I can do actually is this. I can put them in as an equation. I can put this in this equation. So like y equals, so let me write it down here. So y, which is my 6 root 3, let me write it nicely here. So y, which is 6 root 3t minus 4.9 t squared plus 0.01 t to the power 3 is equal to negative, so remember that's negative, and what's my x1? Let me move this a little bit to this side. Negative 6t minus 0.01 t to the power 3. Done. So this is, got that. So I'm going to use this equation. I'm going to solve it. Let's bring it down to my equation. There it is. There it is. So let's break this question down. So I'm going to expand this out because we are trying to show it. I'm trying to expand this out. So it's plus 0.01 t to the power 3 is equal to negative 6t plus 0.01 t to the power 3. Can you see how there's 0.01 to the power 3 on both sides? We can actually cancel these out. There it is. And can you see how there's actually also they all have t? We can actually cancel that t because what, t equals 0 is a solution? No, it's not. Yeah, so that's not what you do. That cancel that, this one cancel that, and that cancel that. So there it is. So remember we're solving for t, so what I'm going to do is I'm going to bring this to plus 6 here, 4.9 t is here. By the way, 4.9 t is just, what is it? I have in my cast, where is it actually? Going back to my cast. 4.9 t is also written as what? So, wait, if I write r of t, actually, it'll give it to me so much simplified. It's basically it's 49. Yeah, it's 49 over 10. What am I doing? 49 over 10. So I can write this here as 49 over 10. So I'm going to multiply both sides by 10, and I should get and actually take the component like a 6 as a factor, so it'll be 60 actually. 60 root 3 plus 1 over, so equals 49t. And divide both sides by 49. And we should get the same thing. Done. We've kind of shown that. Easily. Done. So that's how you show it. Perfect. I've seen actually this question before from one of those past, I don't know, it's like a VCAR paper. That's why it's so important to do as many VCAR questions as possible. All the past papers. Because some of the questions actually repeat. Next question. Find the total distance of the snowboarder traveling while airborne. Give your answer in meters. Correct 2 decimal places. Really, really easy. So we're talking about the path that this path that he traveled. What's the total distance that he's traveled through it? Like this whole path here. And that's easy. So we know, this is just like using your parametric distance formula. So we know distance is equal to the square root of like t1 to t2. So the time, the square root, which is, your dx dt squared, this is your formula sheet, plus dy dt squared dt. because remember, we know what's my x component. So remember, this is your x component, that's your y coordinate. We need to find the derivative of both of them and put them in this equation. Sorry. So let's write the terminals first. Let's write these terminals. So the first terminal, of course, you're starting at 0, t equals 0, and you're going to t equals 2, which is that point of intersection right over here, which we already found the time is this. That's 60, root 3 plus 1 over 49. Done. And so putting this whole formula into this. Okay. What's my dx dt? So I'm going to go back to my CAS, because I've actually done that. Where's my, when we derived it? Yep, d dt, this part. It's this exponent. This is the exponent, and this is your y component. So let's write those down. So 6 minus 3t squared over 100 squared plus the y component is, it's really the wrong one, this one. 100 minus 49t over 5 plus 6 root 3 all squared. Done. dt. And this actually should result us in getting, that's actually so long, what the actual, yeah, it's actually very, very large, is equal to what? So let's write it, equal to, let's put this in our CAS. So it's more easier with the CAS. So we're saying the integral from 0 to, what was it? So 60 times, root 3 plus 1, root 3 plus 1, divided by 49 is equal to square root, bracket here, and it's this component over here, squared, and then the y component, which was over here, all squared. dt. There it is. Enter, control enter, and this is our value. Done. So how many decimal places? We wanted to 2 decimal places, which is 35.5. So your distance is 35. So 38.51 meters. Done. Perfect. And this here question is actually out of the study design. We're not doing mechanics anymore, so I'm going to skip this question. This was mechanics, but yeah, it's taken out of the study design, so I'll put an X on these ones here. So I really enjoyed mechanics, but now they took it off, which actually really annoyed me. But yeah, so I think this is the last question, which is probability, basically. Statistics and probability. Let's do this one. So a paint company claims that the mean time taken for its paint to dry when the motor vehicles are repaired is 3.55 hours with a standard deviation of 0.66 hours. Assuming that the drying time for the paint follows a normal distribution and that the claimed standard deviation value is actually accurate, let the random variable x bar, which is sample mean, represent the mean time taken from the paint to dry for a random sample of 36 motor vehicles. Write down the mean and standard deviation. Really easy typical question. So imagine x is the time, so it's a normal distribution, and so you had a mean of 3.55 where a standard deviation of 0.66 squared. Yep. So if we want to find the mean for the sample mean and the standard deviation of the sample mean, we know that the mean of the sample mean is just the original mean, the one that's original, which is still 3.55 hours. But the standard deviation of the sample mean follows this formula, which is your standard deviation over the square root of n, which is, the standard deviation was 0.66, the square root of n was 36, because we had a sample of 36, which gives me, let's use our CAS here, 0.66 square root 36, which gives me 0.11. 0.11. Yep, 0.11. Done. These are our values. That one here and that one. Next question. At a crash repair site, it was found that the mean time taken for the paint to dry on 36 randomly selected vehicles was actually 3.85 hours. The manager of this crash repair center was not happy and believed that the claim regarding the mean time taken for the paint to dry was too low. To test the paint dry company's claim, a statistical test was carried out. Write down a suitable null and the alternative hypothesis, respectively, to test whether the mean time taken for the paint to dry is actually longer than claimed. A really nice typical question. Let's write this down. So the null hypothesis is like stating that nothing has happened, like the paint was just the same as the original timing, nothing, which was, what was the original, which was the 3.5, nothing actually happened, so it's as the original. But the alternative is actually the claim is actually true, that it is actually greater. It's that 3.85. It's greater than that. So where they claim that it's actually the mean is actually greater than the time taken is actually greater than that 3.55 hours. There it is. So that's really, really easy. Next question. Write down an expression for the p-value of the statistical test and evaluate it to 3 decimal places. Really, really easy. What is the p-value? Well, the p-value represents the like the extreme value. Let me explain. So if I draw a normal distribution here, all right, like a nice normal distribution here, and let's call this, of course, x bar here, like it represents x bar. Of course, this is your mean. This is your mean. All right. So we know that, like, for example, that you know how we know it's 3.85 hours? Where is that 3.8? So wait. So this is, by the way, what the p-value represents is like assuming that the actual null hypothesis is true, so that 3.55 hours is here. So it's the actual mean. We're trying to find like the extreme value where this statement here is true, where you know that let me write that down, that it's right here. So 3.85 here. This value over here. We're trying to find the extreme value where this probability is actually true, where we have a probability that it's actually greater than that 3.85, where this statement holds true, the extreme value. So I hope that makes sense. Like, this is what the p-value represents, where it, we are stating that it's actually, yeah. So I hope that it's like the extreme value. It's really hard to kind of explain in this kind of concept, but yeah, this is what the p-value is. So imagine that's your mean, your actual mean, and this is where we're stating, hey, they're stating that it's 3.85, but the p-value is like the probability that it's actually true, that this is the extreme value where, if it lies within here, we know then it's true. So let's find the p-value. So the p-value is where we calculate it to be where x bar is greater than the 3.85, given that your actual mean is 3.55. Done. So let's put this in our CAS and calculate that. So, all right, go menu, go to probability distributions, and calculate the, go down to, what am I doing? Oh, normal CDF, sorry. So we're going from 3.85 to infinity, where our mean was going back up. So it's 3.55, and your, standard deviation is 0.11. Enter, and this is what you get. This is your p-value. So let's write that down. So your p-value is 0.003 to decimal place, to 3 decimal places. Done. All right. So this p-value over here, this actually probability means this probability over here is actually 0.003. Using a 1% level of significance, state with reason whether the crash repair center is justified in believing that the paint company's claim of a mean time taken for the paint to dry is actually too low. Now we can actually, because we got the p-value, we can actually understand what's happening here. I'm just going to duplicate this and bring it here. Let's think. So to 1 level percent of significant means like so here it is. So let me rub this part out. So imagine that 1%, so that's 0.03, it's actually so small. That level 1% significance, which you can write here, let's say it's right over here, some value here, ... Imagine this whole probability here is 0.01. Your level of significance, yeah? Your level of significance, which is 0.01. Now, can you see how basically what we're saying is if your value here, if our x value here was anywhere here, then it's true that their claim is actually true because it's actually significant. It's within our significance. It's actually, yeah. Whereas, yeah, that's what we're talking about. Where if it's over here, it's not very significant, and hence we state this whole thing is false, and we accept the null hypothesis where, yeah. But look at this. Isn't our probability of p-value so small? It's smaller than our alpha, your significant level, meaning that this value over here is so small. It's around here. It's actually so on the right. It's more on the right. Can you see? That, yep, that this value over here, this over here, it's so like more on the right. This tells me one thing. It tells me that this value over here is it's very significant. Like it's really, really significant. Meaning that we actually have to reject the null hypothesis and actually assume that their claim is actually to be true. That it's very significant. Do you understand what I mean? Like it's so hard to kind of explain, but this over here, this probability is within, it's within your significant levels. Like it's very significant basically. So what we would say here is we would reject, of course, we have to explain, but we'll say, okay, so we say our p-value is actually, it's so small that it's less than the alpha value, which is that 0.01. We reject the null hypothesis, and accept the company's claim, accept the, what did it say, usable reason is just unbelieving. So we reject the null hypothesis and accept, accept that it is justified, that the paint company claim for time is too low. I'm not going to write too much, but yeah. So as p has less than 0.01, we reject that hypothesis and actually accept that it is justified that the paint company claim for time is too low. There it is. That's really kind of easily done. As you look at the 1% level of significance, find a set of sample means that would support the conclusion that the mean time taken for the paint to dry exceeded that 3.5 hours. Give your answer incorrect too. So you know what we're saying? We're like, hey, let's actually let's find the values of x, your sample means, that actually let us give us values that. So let me explain what this is. So if I just kind of rub this out. Okay, so it says at 1%, find a set of sample means values that will support the conclusion that the mean time taken for the paint to dry exceeded that 3.5 hours. So what we're saying is, hey, we want to reject, what are the values that we reject in the hypothesis that, that the company's claims are true? We always want to find, so what x values, the sample means, that will always gives us values where we accept the company's claims and we reject in the hypothesis. So, well, that is easy, isn't it? Because if this, you remember what we said? It's the values that are greater than our level of significance, yeah? You remember how our p-value, our x value here, which was at 3.85, was above our, and the probability, our p-value was greater than that, it was so small than that 0.01. We want to find, basically, this x critical here. So let me move this here. Let me rub this out. We want to find this x critical here. X critical. What this is basically is, if I find, we know that if any value here, by the way, any value here, let me write it. Any value, so this color, let me make it a little bit smaller. Any value here, over here, we actually reject the null hypothesis, and any value here, we accept the null hypothesis. Well, in this case, we want to reject it because we want to always assume that the company's claim is true. That's what we want. So we want to find this x bar, this critical mean, this critical value where where it will give me. So this value, I want to find this value and say, yeah, we want to find this critical. How do we? Well, if I know that this probability over here is 0.01, I can just write it like this. I'm trying to find the probability that x bar is less than this x, mean, and it's equal to 0.99, because you know how I know this probably here has to be, it has to be 0.99 because this one here is 0.01, and I can actually get my x bar, so my critical value. So go menu, probability, distributions, inverse normal. So my area is 0.99. My mean was, going back to my thing, where was it? 3.55. My sample, my standard deviation is 0.11. Enter, and this is my actual value for my, so let's write that down. So my x bar is 3 point, how many decimal places? 3, so 3.806 basically. Done. Now that's not my answer. You remember, we're saying find the set of sample means. Well, we know that now we know this value here, x bar. Basically, we know this x bar value here, which is 3.806. It's the values that are greater than this, greater or equal. You can actually, of course, equal that 3.806. That will always give us values that are, we can reject on our hypothesis. So we can, so your xc value, so your xc value, xc value has to be greater or equal, because it can actually equal that 3.806. These are the values of values that will or we can reject on our hypothesis and always accept that the company's claim is true, that the time it dry exceeded that 3.5 hours. Really nice question. Fine. So if the true mean time taken for the paint to dry is through 0.83. Now we have another, like, mean. Find the probability that the paint company claim is to be not rejected now, at the 1% level of significance, assuming that the standard deviation for the sample to dry is still that 0.66 hours. Give your answer to correct to 2 decimal places. So now, remember this question here was, for E, we said we wanted for it to be, the null hypothesis to be rejected. But now we want it to be not, find the probability that the complex is not to be rejected, assuming that the sample. So we want this basically, it's like the opposite, it's asking the opposite. Now we want it to be, we want to get this probability over here. Right over here. Right over here. We want to now get this probability, basically. What's the probability that it's within this here? Because remember, that's when it's not. If the true mean time taken for the dry is 3.83 hours. So we have a new mean. Find the probability. So we're trying to find the probability that the company's claim is not true at the 1% level of significance, assuming that the standard. Yeah, so not true. So we want it, that they're. If we want the company's claim to be not true, we want to accept the null hypothesis now. So we can we want to accept the null hypothesis so we can reject the alternative hypothesis. So that's what our goal is basically in this one. So remember, this is where we would accept the null hypothesis within here, of course. And these are the values of our x bar. So how do we do this? Well, isn't it just basically finding the probability where x bar is less than this value over here, that 3.806, given our new mean, of course. Our new mean is now that 3.83. Done. Only 1 mark, really nice question there to end the paper. So, which gives me menu, probability distribution, normal CDF. So 3.0. Actually, sorry, let me just copy that, because I want to get this probability distribution that there, my mean is now 3.83, and we're still using the same deviation, which was 0.11, and enter, and we get this. This is my actual value. This is the probability for the company to be not rejected, basically. So 0.41, 2 decimal places. Done. Not too bad. So what I like, this is a really nice paper actually in terms of probability. Really nice typical question. I hope you guys enjoyed this video. I hope it helps you with your revision. Good luck to all students. Have a great day, guys, and take care of yourselves. Bye bye.